All right. So this is going to be the walkthrough with answers for the Empirical Airlines Flight 1023 exercise. So this is, of course, all the instructions. There's been a plane crash. We're going to investigate. It does give us some information about the explosive, okay, the bomb. We have percent composition of that material here. We'll take care of that later. And then we have information that there were victims, including one who appears to have been murdered before the crash. So we have sort of two mysteries to solve here. We have the mystery of what caused the plane to crash, which appears to be a bomb. We have to find out what the bomb was made of and who on the plane might have been carrying it. And then also who was murdered on the plane, and if possible, who might have been the murderer. So we're going to use the information on the following slides to figure that out. So here are the steps we're going to take. We're going to calculate the empirical formula from the compounds listed on the following pages, which are all different slides. So we're going to find out what the compounds were based on the percent composition of each compound for each victim. Then we're going to identify those compounds using a chart that lists a bunch of common compounds with their empirical formulas and what they are commonly used for. So we're going to find the empirical formulas, then use that to identify the compounds. Then we're going to use that information along with some personal information about each victim to match up the compounds with the victims with their names. And then finally, once we put all this together, we're going to figure out who was most likely responsible for the plane crash. We believe it was from a bomb. And who was murdered, and if possible, who might have been the murderer. So let's go through this one at a time. One victim at a time. Victim number one had three compounds. Okay, so we'll call them sort of A, B, and C compounds. Those compounds were found at in various places in and around the victim, in their pockets and in their briefcase, or just in their briefcase in the last compound. The elements that we're going to be working with for all of the compounds, they all have this common set of elements: hydrogen, carbon, nitrogen, and oxygen in different combinations. Some might only have three, some might have all four, but we're going to work through the list for each victim, find the find the empirical formula, and then identify those compounds. And we're going to put all this into a data table, which we have at the end. But first I want to do all the empirical formulas first. So the first compound is 60% carbon. Remember, step one is we're just going to change that 60% to 60 grams. It is 4.48% hydrogen. So that's going to be 4.48 grams of hydrogen. And 35.53% oxygen, which again we're going to convert to grams. Then we're going to divide each of these numbers by its molar mass. Carbon has a molar mass of 12, hydrogen has a molar mass of 1, oxygen has a molar mass of 16. When we divide these out, we get 5, 4.48, and 2.22. Okay, so the next step is to take all of these answers and divide them each by the smallest answer. So the smallest answer here is 2.22. So I'm going to do this for each value. That's 2. And we get 2.25, 2, 2.01, but we'll round it to 2, and 1. Now I can't use the 2.25 in the formula. So as you saw in the video, when you come across a 0.25, the best bet is to multiply everything times 4. Because that converts the 0.25 into a whole number. In this case, it's 9. 2.25 times 4 is 9. And then the others were already whole numbers, but we're increasing those numbers by 4 which now gives me a whole number ratio that I can use as a formula, and that is C9 C9H8O4. Okay, so that's compound A, we're going to call it. And we'll look up what that compound actually is in a minute. Then we have the next compound, which actually has 4 elements. It has carbon, hydrogen, nitrogen. These are all percentages, but I'm converting them to grams or just replacing the percent with grams. And oxygen, okay, divide each one by its molar mass. So 12 for carbon, 1 for hydrogen, 14 for nitrogen, and 16 for oxygen. Okay, we have 5.3, 6, 0.66, and 1.32. The smallest number out of this list is 0.66. So we're going to divide all of the numbers here by 0.66. Which gives us 8, 9, 1, and 2. So that empirical formula, I don't have to do anything else because they're all whole numbers, or they were all really close to whole numbers, so I rounded them. NO2. All right, so that's compound B for the first victim. And then the last one, compound C, we have carbon at 75.42. Hydrogen is 6.63. Nitrogen 8.38. And last, oxygen at 9.57. Plug in their molar masses. You're going to get to know these molar masses really well. Okay, and we have 6.285, 6.63, 0.599, and 0.598. Okay, so divide each one by the smallest one. These two are pretty close, but I'm going to use the 0.598. And 0.598. All right, and we get 10.5. Oops, 10.5. 11. And then these are both going to be close to 1. The 10.5, I can't have the half in there, but if I multiply by 2, that would give me 21, which is a nice whole number. But then I have to multiply everything else by 2, which is something I have to do. 22, 2, and 2. So the empirical formula for compound C is C21H22 N2O2. N2O2. Okay, so that was compound C. All right, so now we have the compounds for victim A, or victim 1 rather. And I'm going to go ahead and I'm going to put those into the table, which is back here. Okay, so victim A, we had the first empirical formula was C9H8O4. The second one was C8H9NO2. And the third one, which we just found, was C21H22N2O2. And let's see, this was found in pockets and briefcase. and so is this one. And the last one was found merely in the briefcase. All right, so what are these compounds? Well, let's take a look at the chart. C9H8O4. That's right here. That's aspirin. All right. C8H9NO2 is acetaminophen. And then C21H22N2O2 is strychnine. All right. So I'm going to go back. I'm going to do the rest of the empirical formulas before I start trying to figure out who's who here. Because the information, the personal information might help me with that. All right, so next one. Victim number 2 had 2 compounds, one found in their briefcase, one found in their stomach. So we'll call it A and B. Okay, compound A has 63.15 carbon, 5.3 hydrogen, and 31.55 oxygen. So divide them by their molar masses, and we get 2.67, 5.3, and 1.97. Oh, sorry, this first one. Stay there. No, one step ahead. It is actually 5.26. So we're going to divide those each by the smallest of these numbers, which is the 1.97 at the bottom. So that gives us 2.67, 2.69, and 1. The 2.67 and the 2.69 we can't use. When you come out to something around 2.66-ish to 2.7 roughly, you want to multiply by 3. And then we get 883. So the formula is C8H8O3 for that compound. All right, compound B, and that was in the briefcase. Okay, and then we have carbon 46.66, hydrogen 4.48, nitrogen 31.1, and oxygen 1776. All right, plug in those molar masses. We have 1.11, 2.22, 4.48, and 3.88. The smallest number out of all these is 1.11. With which we get 3.495, which is basically 3.5, 4, 2, and 1. Since I have 3.5, I can't use 3.5. I multiply by 2, which makes it 7. Makes this 8. Makes that 4. And makes that 2. So the empirical formula of this compound is C7H8N4O2. Okay, and that was found in the stomach of this particular victim. So let's go to our chart. Fill in victim number 2. Okay, we have C8H8O3. And we have C7H8N4O2. C7H8N4O2. All right. This C8H8O3 is vanilla. Okay. C7H8N4O2 is bromine. And this was in the briefcase. And in the stomach, implying that this person ate whatever that was, or ingested it somehow. All right. Back to victim number 3. Only one compound here found in their pockets. Carbon 71.68, hydrogen 6.94, nitrogen 4.68, and oxygen 16.03. Divide by molar masses. And we've got 18. I'm sorry, we don't have 18. Again, I'm looking ahead. Sorry about that. 5.97, 6.94, 0.33, and 1. The smallest number out of these is 0.33. All right, so now when we do this out, we get 18.1, we get 21, we get 1, and we get 3. So the 18 is close enough. I'm going to round it. We've got C18H21, NO3. All right, filling in the table. C18H21, NO3. That compound is codeine. And it was found in that victim's pocket. Victim number 4. One compound. 15.87 carbon, 2.2 hydrogen, 18.15 nitrogen, and 63.1 oxygen. Molar masses, we get 1.32, 2.2, 1.3, and 3.94. So divide them all by the 1.3. So that's the smallest number here. And we get 1, 1.7, 1, and 3. So the 1.7, again, if you get something around between 0.6 and 0.7, best bet is to multiply everything times 3. 5, 3, and 9. So this is C3H5N3O9. Victim number 4. C3H5N3O9. That's a 9, and that is a 5, just to be clear. All right, that compound, 3539, is nitroglycerin. Okay, nitroglycerin, and that was found in blood and pockets. So that suggests that that person was carrying nitroglycerin and also had it in their bloodstream, which again means they ingested it at some point. All right, number 5 has 2 compounds. First one, compound A, 75.42, 6.63, 8.38, 9.57. Molar masses, and we get 6.285, 6.63, 0.599, and 0.599. Now this will happen sometimes. You have more than one of the smallest one. That's okay. Just divide everything by that. So we're actually dividing two things by themselves since they match. And we get 10.5, 11, 1, 1, 10.5. I'm going to have to multiply that times 2, which means everything gets multiplied by 2, 2, 2, 22, and 21. So that formula is C21H22N2O2. Second compound is C37H22, 2.22, 18.5, and 42.27. Plug in the molar masses. Here we go. Okay, this is 3.1, 2.22, 1.32, and 2.64. Divide them all by the smallest number, which is 1.32. Okay, and we get 2, 1, 1.6, and 2.35. So we have a 0.35 and a 0.6. Both of those actually indicate you should multiply by 3. So we end up with 6, 3, 5, and 7. So the formula is C7H5N3O6. All right, let's fill in that victim on the table. Two compounds. First one was C21H22N2O2. And the second one was C7H5N3O6. So C21H22, we've actually seen that one before. That's the strychnine. And it was found in this victim's blood. So that suggests that they ingested it. And strychnine is a poison, so that's not good news. And then C7H, that's a 5. C7H5N3O6 is here. Trinitrotoluene, also known as TNT. That was found in their luggage. So that's also not good. So this person had poison in their blood and TNT in their luggage. All right, so we just have a couple of victims left to go over. So let's go back to number 6. Okay, victim number 6 has one compound, which is 57.14 carbon, 6.16 hydrogen, 9.52 nitrogen, and 27.18 oxygen. Fill in those molar masses. Divide. We we get 4.76, 6.16, 0.68, and 1.698. This should be a 6. The smallest number out of all of these is 0.68. So divide everything by 0.68. Which gives me 7, 9, 1, and 2.497. Of course, right? Couldn't be that easy. Multiply everything times 2. We get 5, 2, 18, and 14. So the empirical formula here is C14, H18, N2O5. Let's put it on the chart. C14, H18, N2O5. That is aspartame. Right, victim number 7. 2 compounds. One in the briefcase, one in the luggage. Number 6 was in the briefcase. Didn't put that in there. Briefcase. All right, now back to victim 7. First compound, 81.5 carbon, 7.5 hydrogen, 9.39 nitrogen, and that is also oxygen, 2.68. Divide by molar masses. We get 6.79, 7.5, 0.67, and 0.17. That 0.17 is the smallest. Everything gets divided by 0.17. So that's going to give us some big numbers here. 40, 44, 4, and 1. Now this time it was that easy. We don't have to multiply anything extra. C40, H44, N4, O. And then the second compound is 81.58 carbon, 8.9 hydrogen. This one doesn't have any oxygen. The nitrogen is 9.52. Divide by molar masses. You get 6.798, 8.9, and 0.68. Divide them all by the smallest, which was 0.68. And we get 10, 13, and 1. Hey, 2 in a row that we don't have to do anything extra. Okay, C10, H13, N. Put those in. C40, H44, N4O. That is curare. And it was in the briefcase. And then C10, H13, N is dimethicrin. Which was in luggage. Right, last one, number 8. One compound, C67.31, H 6.96, N 4.62, O 21.1. divide by molar masses, we get 5.61, 6.96, 0.33, 1.32. Smallest out of these numbers is the 0.33. Divide everything by 0.33. We get 17, 21, 1, 4. No extra money. These last three, getting lazy here at the end. So that's C17, H21, that's 21, N104. Okay, last compound here, C17, H21, N04. Find that on the table. That is the narcotic cocaine, which was found in blood and luggage. All right, now let's see if we can figure out who these people are. Aspirin, acetaminophen, and strychnine. Well, let's see, based on the personal information. Personal information over here. Aspirin, acetaminophen is Advil. So someone who has aspirin and acetaminophen would make sense that that was someone who works for a pharmaceutical company. So we're going to say that that is Curie drugs. They also had strychnine in their briefcase. Strychnine is a poison, so that's suspicious, to say the least. All right, the next one had vanilla and theobromine. Well, the vanilla obviously is a flavor, and the theobromine is also a flavoring. So this person had vanilla in the briefcase and chocolate flavoring in their stomach. That might be someone like Kelvin Donut, since they're a baker and they make pastry. All right, 2 down. Next, someone who had codeine in their pocket. Well, codeine is a painkiller, so we have the professional athlete suspended for drug violations, and then we have someone who's severely depressed, and we have somebody who recently underwent dental surgery. So that is very likely to be where you might use codeine. Dalton Moeller. All right, next person had nitroglycerin in their blood, which means they ingested it, and in their pocket, which means they might have been carrying some. The nitroglycerin, it's an explosive, which could be suspicious, but if it was in their pocket, I'm assuming it was a small amount. And it's also a heart medication. They had it in their bloodstream. So someone who has a heart medication would be someone like the pilot with the heart condition, Amadeo Aviator. All right, the next one had strychnine, which is the poison that Curie Drugs had in her briefcase, but they had it in their blood, which means they ingested it. So that's not good. That is likely to be someone who is been poisoned. And they also had TNT in their luggage, which if you go back and look at the percentages, that's the same percentages as what was used in the bomb that blew up the plane. So who might that be? Well, member of a terrorist organization whose goal is to make everyone aware of the power of chemistry, Norm Einstein. All right. Last couple people here. Somebody who has aspartame in their briefcase. Aspartame is an artificial sweetener. If you like diet soda, you know what it tastes like. And if you don't like diet soda, you probably really know what it tastes like, because it's the stuff that makes diet soda taste terrible if you don't like it. Someone who's addicted to sugar-free drinks would be exactly the sort of person who would have something with artificial sweetener in their briefcase, and that's Boar Diet, as in boring diet soda. All right. right, a couple more. Somebody who has curare, which is a poison, and dimetacrine, which is an antidepressant, a prescription antidepressant. So this is somebody who's probably not in very good shape. Somebody who is severely depressed. So they're taking an antidepressant. They're also carrying curare, which might suggest that they're in a very bad way. So Ruthie Ford, recycle. I'm just going to go with Ruthie Ford, recycle, which means the last person on the list is the one who has been taking cocaine because it's in their bloodstream and also in their luggage. That sounds like an athlete who might have been suspended at some point. Democritus. All right, so now, final questions. Why did the plane blow up? A bomb made of TNT. Who was most likely to blame? That would be Norm Einstein, because he had the TNT in his luggage. Who was murdered? Well, I'm going to go ahead and say the person who was murdered is the person who had the poison in their blood. And that actually is also Norm Einstein. Irony. So they were not only responsible for the plane crash, but they were murdered before it crashed. So that's just bad luck on a lot of fronts. And who most likely did it? Well, probably the person who was carrying the strychnine with them, which is Curie drugs. Okay, so there you go. That's the whole ball of wax. All the empirical formulas, all the identified compounds, and the answers to the question of what happened on the plane.